Hello everyone, my name is James Graw and I am with Risk Management Professionals. Today we'll cover the Nevada Division of Environmental Protection, or NDEP, Mechanical Integrity, or MI program, which includes how the NDEP CAPP program, or Chemical Accident Prevention program, differs from federal regulations and common deficiencies in mechanical integrity programs. This is the first of a series of presentations we'll broadcast on how to achieve compliance with CAPP regulations. And the reason why we are beginning with the mechanical integrity element is that the MI element of CAPP standard has been a difficult element for many facilities to implement. The results of audits have consistently demonstrated that MI is a CAPP element, receiving a large number of citations at most facilities. This is not to say that inspection, testing, and preventative maintenance programs do not exist at CAPP-covered facilities, nor that the maintenance programs at these facilities are breakdown-only programs, where equipment is only maintained after it is broken down, instead of conducting preventative maintenance. Preventative and predictive maintenance programs have existed in the chemical process industry for many years. What have been lacking in some cases are complete integrated MI management system programs that address all the sub-elements of MI, as it is defined in the CAPP standard. Risk Management Professionals provides high-quality services to assist in your RMP and PSM needs, as well as other key services as outlined in this slide. The agenda for today's presentation is to first dive into the definition of mechanical integrity and the elements that are typically found in an MI program. I will then introduce some of the unique aspects of the CAPP MI program and how to correctly incorporate them into a facility's MI program. Then we'll discuss some of the common pitfalls and good characteristics found in MI programs. To begin developing a mechanical integrity program, we first need to look to its definition. When reading the first bullet point, we'll notice that several things are unspecified, one being that equipment is not accurately defined. This is because mechanical integrity applies to various industries, regulatory requirements, geography, and plant culture. So to begin developing an MI program, facility management needs to decide which equipment items are to be included and at what level of detail. Similarly, improving an existing MI program for those facilities that already have one requires confirmation that these decisions were made correctly and are implemented consistently. As one looks through the Nevada Administrative Code, or NAC, detailing the procedures for maintenance of equipment, it is important to note that this component, basically laying out the entire mechanical integrity requirements, is not the only one that is necessary for compliance with the CAPP program. There are also management systems and document control that needs to be in place. The MI element of the CAPP regulations is written in very broad performance-based language, even more so than the remainder of the CAPP standard. Interpretation of these broadly stated MI requirements and the matching of these requirements to actual facility policies, practices, and procedures can be a difficult process. There is still a distinct impression by some that MI means only preventative maintenance, and therefore MI is assigned solely to the maintenance department or group. Actually, because MI includes a wide variety of tasks and activities, the responsibilities for MI activities are spread widely across the facility, and many of these personnel may not realize that their job includes an activity that is regulated as part of the MI program. This is reflected in the Nevada CAPP program, which also has an element where document control and management systems are laid out, which will also be gone over in an additional webinar. Moving on, MI activities cover the entire life cycle of the covered equipment, not just the ongoing maintenance activities, and therefore many requirements of the MI element may not be completely implemented. On this slide, I have two cutouts from the Nevada's helpful guidance on developing mechanical integrity programs. These are listed for each CAPP element on the NDEP's website, and we'll have a link to that later on in the presentation. Looking along the left-hand side, we see the scope of the mechanical integrity standard, which can be a little bit confusing because this list appears to be incomplete, and several clarifications are necessary. Pressure vessels that are not registered vessels and are operated at less than 15 psig should also be included in the MI program if they contain CAPP-covered materials. Heat exchangers are either vessels or components in a piping system, and therefore should be included in the MI program if they cool or heat CAPP-covered materials. Piping system components includes any mechanical device that is installed inline in the piping system and is exposed to the CAPP-covered materials inside the piping, such as filters, strainers, flanges, gasket materials, and valves of all kinds. Relief and vent systems and devices includes all components that are used to control pressure, for example, relief valves, rupture discs, conservation vents, vent systems, etc. Controls would also include mechanical systems or devices that are intended to terminate or control exothermic reactions, pressure transients, or other types of process safety hazard scenarios, or to mitigate the results of such a scenario, for example, a water curtain or quench system. Controls could even include local instrumentation that is intended to be ready by operators so that they can then take action to terminate or control abnormal conditions. Rotary machinery includes all equipment contained or exposed to CAPP-covered materials as well, including pumps, compressors, fans, etc. However, there are also equipment types that are clearly important to process safety that should be carefully considered for the inclusion in the MI program. The CAPP standard does not explicitly require that these types of equipment be included in the MI program. However, they are not included in the MI program, either formally or informally. The risk of process safety scenarios involved in CAPP-covered equipment may be higher because the following concepts will not be completely applied to process safety and are key safeguards in reducing the severity and/or likelihood of process safety scenarios. Some examples of this would be employee alarm systems, structural or civil systems that support the weight or movement equipment otherwise included in the MI program, key utility service systems or components of equipment included in the CAPP program, such as electrical power, air, steam, inerting or nitrogen, cooling water, refrigeration, etc. Fire protection equipment, fixed and portable area monitors that would detect the release of toxic or flammable materials, second containment systems for tanks, ventilation systems, or transportation of containers used to transport CAPP-covered materials via air, water, rail, or ground. Here we have a list of the elements of mechanical integrity programs that are required per the NAC standard. Looking at inspection, testing, and preventative maintenance, or ITPM procedures, are important because written procedures can help ensure that MI program activities and tasks are performed adequately, safely, and consistently. This is the primary reason the NDEP included a requirement to develop and implement procedures for MI program activities. The ITPM training program is important because training helps ensure not only that qualified personnel perform tasks, but also that MI tasks are performed appropriately and consistently. Reducing human errors will greatly reduce the overall rate of equipment failures. Next, although quality assurance and control is sometimes ignored because it can be difficult for an external auditor to judge, an effective QA program can be a powerful tool for upgrading a plant's entire mechanical integrity program. Next, we have the management plan and document control, which in successful MI programs is characterized by supervisors and managers emphasizing how each person contributes to preventing incidents and improving process reliability. Document control ensures that personnel are operating with respect to current documents. Finally, we have continuous improvement, which is not directly outlined in the NDEP standard. However, continuous improvement is present at successful facilities, which have the objective and desire to continuously improve the program. This should be part of the work culture and is conducted via periodic audits of program activities, establishing performance measurement systems, and learning from equipment failures. The NDEP website also provides a checklist that we recommend you include for internal audits before the auditor comes on site, so it can be best used to integrate these worksheets into your facility's internal audit system. Once the scope of the MI program has been defined, the MI program efforts often focus on developing the ITPM program. The term preventative maintenance does include all proactive maintenance tasks outside of inspection or test tasks that are performed to prevent or predict failure of equipment included in the MI program. Also note that the preventative maintenance is not intended to imply that every task traditionally viewed as a PM task is included in the MI program. In many respects, the ITPM program is actually the core of the MI program. It focuses on identifying and implementing maintenance tasks needed to ensure the ongoing integrity of equipment. On the PowerPoint, you see one example of a checklist found on ndep.nv.gov that can be used to maintain facility programs internally. This checklist can be used as a starting point as it is intended to be comprehensive. It actually reflects the compliance audit worksheets that regulators use when they come on site in order to review your mechanical integrity program. So this is something that we recommend using in order to maintain and internally audit your mechanical integrity system. On this sheet, you can see that equipment is listed on the left and maintenance sources are listed as additional categories. This is one great way to ensure that all maintenance sources are covered. So we get a couple questions regarding the NDP standards. The standard states that the owner or operator of a facility with a process that is subject to CAPP shall establish and implement written procedures to maintain the ongoing integrity of equipment. This means that the preventative and corrective maintenance tasks that are performed on covered equipment must be written down. What isn't defined and what we get questions on are what kind of format should be used for the procedures. And they can actually be separate document embedded in work orders, attached to work orders, or be part of a separate manual. Another question is regarding OEM manuals. Can they suffice? In general, it seems to be acceptable for OEM manuals to be used. However, these procedures should be as up-to-date and complete as the OEM has generated for that type of model and equipment. This would also elevate the OEM manuals to the same control document status as other internally generated site procedures. We also get questions on how detailed the procedure should be and how much of a maintenance technician's training can be relied upon without generally high detailed procedures. In general, simple tasks such as lubrication do not require detailed explanation in the maintenance procedures. However, the level of detail must be consistent with the complexity of tasks to be performed and the level of skill of the maintenance workforce. We also get questions on how often, if any, should the maintenance procedures be reviewed and updated, and should they be certified periodically like SOPs. Formal certification on the annual basis is generally not warranted for maintenance procedures. However, some sort of periodic review and update is prudent, as the CAPP program actually requires that this be updated as PSI is updated in order to change the maintenance of equipment. So there needs to be some kind of system in place in order to monitor the PSI and trigger a change to the mechanical integrity program. More on that will be included in some of our other webinars. Next, we have a question regarding should the maintenance procedure contain safety and health information and precautions. This information should be included or referenced in the work order or procedure. If using maintenance procedures from OEM manuals, site-specific safety and health information should be added to the work order. Finally, we get questions on having the maintenance procedures formally approved. The provision of the document control system or any control procedure on site should be followed, and with CAPP it is required for approval of these procedures. In application to documentation, the NDEP standard states that the owner or operator of a facility with a process subject to CAPP shall ensure that inspections and tests of equipment are performed, 1, in the frequency required by good engineering practices and are consistent with any applicable recommendations from the manufacturer of the equipment, or 2, more frequently if determined to be necessary by previous experience in operating the equipment. This infers that equipment manuals should be maintained and their installation, operating, and maintenance manuals documented within the MI program. They are used to construct the maintenance type and frequency. Facilities often maintain these electronically as they're easier to access. And generally, we see facilities use the most conservative estimates of these items, whether it's the OEM manuals or other standards, in order to determine the initial inspection frequency of their equipment, and then from there they can use operator experience in order to make it less frequent and more practical. NDEP's guidance states that the frequency of preventative maintenance must be determined to be the most conservative of vendor recommendations, best engineering practices, or operating experience. This means that both OEM manuals and applicable standards must be on hand to provide evidence for conservative maintenance frequencies. The standard also states that the owner or operator of a facility with a process subject to CAPP shall document inspections and tests as they are performed on the equipment, including without limitation, documentation of the date of inspection test, the name of person who performed the inspection or test, the serial number or other identifier of the equipment on which the inspection test was performed, and the results of the inspection test. This can lead to complexity as the process grows. So NDEP has a recommended format for storing procedures, seen in the image on the screen here. Maintenance procedures are referenced based off their respective process units and equipments. The procedure can be stored separately within a facility's document control system to ensure the most up-to-date copy is in circulation. And whatever tracking documentation system are used at the facility, it must also be standardized at the facility. This brings us to the next element of the NAC code, which states that inspection and testing shall follow recognized and generally accepted good engineering practices, or RAGAGEP, constantly said as RAGAGEP. RAGAGEPs provide guidance on engineering, operating, or maintenance activities based on established code, standard, published technical report, or recommended practice. They're documents that provide guidance on engineering, operating, or maintenance activities based on an established code, standard, published technical report, or recommended practice. Many of these documents were developed after obtaining broad industry and expert public technical input, and many were accepted by consensus of industry and technical organizations. Nevada mandates the use of RAGAGEPs. To effectively use a RAGAGEP with a successful MI program, facility management must determine which practices are available and assess the applicability of each practice to their facility and establish data records to determine the ongoing applicability and use of each standard. Codes, standards, and recommended practices continue to evolve, so companies should have management systems in place to keep up with new standards and with changes to existing standards. For example, some of these that we commonly see are API 572, which is specifically for pressure vessels. It incorporates a service record that should be established after the first inspection on any on-stream methods or external examination. We also see API 510, which covers maintenance and inspection of pressure vessels, API 570 and 576, which are piping inspection codes for repair, alteration, and re-rating, inspection of pressure relief devices as well, and the American Concrete Industry, American Institute of Steel of Construction, American National Standards Institute, etc. Next, we have training, which is important once you have your procedures established to conduct for employees to make sure that they understand and can implement your ITPM procedures. The NDP standard states that the owner or operator facility with a process subject to CAPP shall provide each employee who is involved in maintaining the ongoing integrity of the equipment with an overview of the process that uses the equipment and the potential hazards of the process, as well as training in the procedures that are applicable to the job tasks of the employee to ensure that the employee can perform the job tasks in a safe manner, and training in the program for management of change developments to be implemented. We'll cover this more in another webinar, but it must include instruction on how to recognize activities that are not in replacement in kind and thus would trigger an MOC or management of change. The requirement that training be provided as applicable to an employee's job tasks to ensure that they can perform it in a safe manner causes the most confusion from what we've seen. The broad regulatory statement infers the following. 1, that requirements for the process overview, potential hazards, job tasks, and how to recognize a change that would prompt an MOC. 2, training in the safe practices that maintenance technicians are required to perform their work. The venue, type of training, frequency of training, and competency tests needs to be documented. 3, that training and/or qualifications in the general craft and specialty skill that were required to perform their work. However, this does not mean that a company needs to establish a formal apprentice program. And 4, a special subset of general craft skills includes specialty skills that require certification of the skill by an outside agency. This includes welders, API pressure vessel tank and piping inspectors, non-destructive testing, vibration monitor technicians, and thermography technicians. Training itself is defined in another standard, but in application to the mechanical integrity program, the following can be considered. Training is used to identify gaps in knowledge of current workforce and to evaluate new hires. Knowledge of weakness allows a facility to develop training and seek outside assistance to address the greatest training qualification needs. To develop a training program, you can actually perform a review of the MI program's components, such as inspection, testing, and preventative maintenance plans, quality assurance, and common repair activities. Then develop a list of job classification for the personnel who will perform the tasks. Solicit input from your experienced, knowledgeable personnel, and assemble a list of the skills and knowledge required for within each job classification and subclassification. Then survey the workforce to determine which skills and knowledge areas are needed to improve. Survey supervisory personnel to obtain their input on the skill knowledgeable base of their workforce, and identify the skills, knowledge, or gaps of the existing workforce to identify requirements for promoted personnel and new hires. You can see how this requires a lot of communication between management and facility personnel. And that is why initially OEM manuals are so necessary to develop maintenance frequency and type of inspections, but also in RAGAGEP you see that operator experience is also a key element to consider when developing your mechanical integrity program. Refresher training is also another component of the training program that is essential. Traditionally, facilities provided training on new equipment with introductory classes taught by vendors and or project engineers associated with the equipment. In other cases, companies have sent employees to a factory school. Such courses may still be appropriate. However, the training program should also consider how the next person will acquire these new skills. That is, how will the facility train personnel who did not attend the class? In order to evaluate your introductory classes, you can ask, what knowledge and or skills did the class attendees acquire? Are sufficient resources available to prove this training in-house? Was the class useful and should it be repeated in the future? And does it make sense to train each worker individual, or should several workers be trained together? This is a good evaluation of the practicality of your training. Looking at common characteristics of a good MI program, we first have quality assurance and control, which is not just prescribed by the CAPP mechanical integrity program requirements, but is also a good element to have when you're operating outside of Nevada. This is because the QA/QC requirements include activities that ensure equipment is designed, fabricated, procured, installed, operated, and maintained in a manner appropriate for its intended application. This is mentioned by the NAC code, as we were saying, 459.95421 sections I through J, and included as an element of the checklist guidance provided on NDEP's website. As can be seen in the guidance checklist, the new and existing system must be described in order to confirm that new components are compatible with the existing system, that installation is per design specifications and vendor instructions, and it also confirms that the proper materials are specified, those materials are ordered and received, and they're also installed. So this develops some kind of tracking mechanism to ensure that maintenance is conducted with the correct materials. This is normally addressed through the MOC and or PSSR programs, which refer to Management of Change and Pre-Startup Safety Review, respectively. These will be addressed in another webinar. Other common characteristics of a good MI program are where the MI program clearly designates equipment included in the program based on defined criteria, prioritizes equipment to help optimally allocate resources such as personnel, money, and storage space. It helps plant staff to perform planned maintenance and reduce the need for unplanned maintenance. It incorporates RAGAGEP. It helps plant staff recognize when equipment deficiencies will lead to serious accidents. It helps ensure that personnel assigned to inspect, test, maintain, procure, fabricate, install, decommission, and recommission process equipment are appropriately trained and have access to appropriate procedures for these activities. It maintains service documentation and other records to enable consistent performance of MI activities and to provide accurate equipment information to other users, including other process safety and risk management elements. Another big discrepancy is that MI programs won't match PSI or vice versa. One could be updated without the other. This is why it's called out specifically in the management plan, who is specifically required to review PSI prior to MI changes. And finally, utilizing the CAPP's online guide for internal audits in preparation of external audits is a great way in order to confirm and pass Nevada audits. So we generally make the following recommendations in preparation for an audit. The first one is to use the audit worksheets and data forms during program development and updates. These can be used to develop the program and are clearly defined expectations of what should be incorporated into the mechanical integrity program and can be used as a checklist when you're going through everything. Second is to fill out the audit worksheets as an internal practice. These are living documents, so if things are lost along the development of the process, it can lead to redundancy where you have to go back and look and see everything that you have. All the audit worksheets are available on the NDEP website at the link below. And not only can guidance be found here, but also the Word and PDF files of the actual audit sheets used when a regulator comes on site. Looking at common deficiencies of an MI program, we see the lack of current or written procedures for a task or activity. So a regulator could ask an operator, walk me through how you normally start up a compressor. And if that doesn't match up with the documented operating procedure, you're going to have a violation there. And this isn't because the regulator is trying to be a stickler. However, it's for the process safety where the compressor isn't operated outside of its desired function. The next item is discrepancies between the written procedure steps and actual training. In this case, training can be conducted on incorrect written procedures, causing confusion in the actual operating parameters of a unit. Next, we have the failure to follow written procedures, usually because of inadequate or missing or confusing or incorrect information in the procedure. A facility culture that does not support procedures as the accepted way to perform the task or activity could also lead to the same issues we just discussed. Insufficient management systems that ensure procedures are followed would also fall into this category, as well as the existence of multiple or conflicting procedures. Finally, lack of personnel training on the procedures is in and of itself a common deficiency of MI programs. In conclusion, you can reasonably expect an MI program to include improved equipment reliability, reduced equipment failures that lead to safety and environmental incidents, improved product consistency and maintenance consistency as well as efficiency, reduction of unplanned maintenance time and costs, reduced operating costs, improved spare parts management and contractor performance, and also compliance with government regulations. What we commonly recommend is a holistic approach where MI programs as a company priority are used rather than something that the company is forced to do. This approach helps to ensure compliance because personnel are less likely to take shortcuts. Next, create synergies with the equipment and process reliability initiatives that could improve results and/or lower costs. And finally, address actual risks to employees, communities, and the business. The following are the references that we used in the generation of this webinar. Finally, if you have any questions or comments, you can contact me at my email, which is on the screen. You can also contact our office at the phone number on the screen and find out more about our company on our website. Thank you very much. I hope you enjoyed this presentation.